This is going to wrap up our final lesson for Chapter 3. We're going to do some word problems with both exponential and log applications. And it is very important that you read the problems because the problems are pretty basic. It's going to tell you exactly what we're looking for. So for example, on problem number 1, we know the population of a city is modeled by that exponential function where t represents 0 from 2000. So again, in reference to 2000 is pretty important. According to this model, when will the population reach 150,000? So P is the population, so we're going to substitute in 150 or 150,000 for P. So let's go ahead and get started here and see what we need to do next. So we're just dropping that in for for the P because that is the total population. And I'm just now recopying the rest of the problem. Okay, right away I can see that I need to divide both sides by the number in front of the letter E. So we're just going to divide both of these by the 105,300. So what we're going to end up with is the exponent is going to be all by itself over here on the right side, which is exactly what we want. And then we're just going to go ahead and do 150,000 divided by 105,300. And I don't really want a decimal, so I'm going to use my fraction to decimal changer there. So, oops, I did that too quick. So that's going to be 149 and 351. Now that's going to be a whole number there. So the way that we're going to get around that is, remember the denominator is 351 and I have a whole unit because this is a mixed number. So 149 plus 351. So my top number is 500 and my bottom number is 351. And guys, I'll be happy to show you that in class what I just did. I just converted my fraction to an improper fraction. Okay, so now that we have that, remember, can I make this a base of E? No, I cannot. So now we're going to go ahead and convert it to log form. So this is going to be ln. And that takes care of the E. Remember, the argument hops over to the same side where the log is. And remember, logs always equal exponents. So now we have that there. I'm going to go ahead and solve for t. We're going to divide both sides by 0.015. So my t is going to become equal to the natural log of 500 over 351, and all of that's going to be divided by 0.015. And I'm just going to type this into the calculator and get an approximate answer here. So natural log of 500 divided by 351. Okay, so that's the numerator. Don't forget it's being divided by this fraction. All right, so t is approximately 23.6 years. So let's go ahead and answer the question. When will the population reach this total? Now remember, this is how many years from 2000. So when will the population reach the total? It will be in the year of, well, actually this year, 2023. It's going to occur during this year. Okay. So let's go ahead and take a look at number 2. Number 2 is about bacteria. All right, so for problem number 2, we know that we are going to have bacteria modeled by the total number modeled by this function, where t is the time in hours. So we're given the total of 300, and we also know the time. What we're going to do is we're going to find the time required to quadruple its size. So guys, this is kind of a two-step problem here. This is definitely multiple steps. The first thing we're going to do is find K. Then we're going to find the new hours for that, which is denoted by T. All right, here we go with step 1 to find K. So let's go ahead and plug in the 5 hours there for that exponent of t. So we're going to have also the letter n substituted with 300. N is 300. So 300 equals 100 times e to the kt. And remember, t is 5 hours. I'm going to put the 5 first. So that exponent is going to be 5k. All right. Now again, exponents need to be by themselves. We're going to divide both sides by 100. So that's going to be 3 equals e to the 5k. And again, I can't make 3 a power of e. So here we go. We're going to convert this to log form. So ln of 3 equals 5k. So we're going to divide both sides by 5. So k is going to equal ln of 3. And remember, all of that is divided by 5. So let me go ahead and put that in the calculator and get a rounded answer for our constant. So again, ln of 3, and don't forget we're dividing by 5. So my k value, and we'll round,